Welcome, Algebra 2 team, to our Unit 2 Study Guide number 2 video. So we're taking our test pretty soon. We've got 13 problems to knock out today and not a whole lot of time to do it, so let's jump right in. Number 1 on your test is going to ask you to identify if these are real or imaginary. So let's go over one basic rule. You learned this in one of our first lessons this unit, that the square root of -1 is a special character called I. That means it's imaginary. Whenever you have a square root inside, that's the key, inside the square root, whenever you have a negative inside the square root, we're talking about an imaginary number. Also, you learned that if you have I times itself, right, I squared, that comes out to a -1. So these are our two rules that we need to keep in mind for these problems. So let's look at the first one, the square root of 7. Well, I don't know what the square root of 7 is off the top of my head, but I know it's a real number because there's no negative inside. So if I type this into a calculator, it'll give me something, right? It'll give me like 2.35, I don't know. But it's a real number. Look at B now. Very similar, but this one has a negative inside. So because of the negative inside, I know that that is going to be imaginary. Similarly, if I asked you for the square root of 25, you would say that's a real number. The number times itself that gives me 25 is 5. On the other hand, if I said what's the square root of -25, the answer would be, well, the inside negative turns into an I, and then the square root of 25 I know is 5. So again, negative inside means we're imaginary. Let's look at the next problem, C. So this one looks a little different. It has an I in it already. But we can't just jump to conclusions. We actually have to work this out and see if it's real or imaginary. So here's what I mean by work it out. 3i squared means take 3i and multiply it by itself 2 times, right? Square it. So let's do this one at a time. Let's go ahead and multiply these two and see what we get. That negative in the front is going to stay while we multiply this out. So 3i times 3i gives me 9i squared. And ooh, I see something familiar here. This I squared is a definition. Whenever I see it, I'm going to replace I squared with -1. So really I have -9 times -1. Notice that we no longer have an I involved. This will leave me with a +9. And my friends, +9, we know, is a real number. So whenever you see something like this, ask for real or imaginary, go ahead and multiply it all out to get your answer. If you understood that and you want to try some on your own, go ahead and write down these problems. At the end of this video, I'll link you to the solutions so you can go ahead and test yourself. Like, did I actually learn this? Because this is what your test is going to look like, right? I'm not going to be explaining how to solve these on the test, so go ahead and give yourself your own mini practice exam. Okay, so pause the video, write these down, and then at the end of the video, you'll check your answers. All right, so let's move on to number 2. Number 2 gives me two functions. All right, we have f of x defined right here, and we have g of x. We are asked to do several operations. So let's start with number 2a. Here, it's asking me to, careful, it's asking me to add the functions. So if I'm asked to add them, all I'm going to do is substitute. Well, what's f of x? It's 5 minus 2i, and I'm going to add that to, you know what, why don't I go ahead and use parentheses, because that's good practice. So it's going to be f of x, which is 5 minus 2i, plus g of x, which I know is 3 plus 6i. All it wants me to do is to add these guys. So this is what I'm not going to do. I'm not going to distribute. Some of you may be tempted to do that right away because you're used to it right now. But this is saying to add. So all we're going to do is bring down our parentheses because there's nothing to distribute in here, and there's just a positive 1, so there's really nothing's going to change there. And let's go on from there. We're going to add that to 3 plus 6i. Now I'm just going to treat my i's like a variable and combine my like terms. So I have 5 plus 3 gives me 8. Those are a couple of like terms. And I also have negative 2i plus 6i gives me plus 4i. And I'm done. That's it. I just added them. Let's look at letter B. In letter B, it's asking me to subtract. So I'm going to use my parentheses like always. So f of x is 5 minus 2i, and I'm asked to minus g of x. That's 3 plus 6i. Now in this case, I don't just bring the parentheses down. It's important that we notice why it's useful here. So we have this negative 1 that we need to distribute, and what's going to happen when we distribute is it will change both of these signs. Okay, so careful. I have 5 minus 2y, but this positive 3 is going to change to a negative 3. And negative 1 times 6i makes that a negative 6i. So notice both of the signs changed. Now we're going to go ahead and combine our like terms. So we have got 5 minus 3, which is 2, and negative 2i minus 6i, which is minus 8i. Okay, if you wrote these in a different order, you could have gotten negative 8i and then plus 2, and that's the exact same thing. Both of these are correct answers. All right, now let's look at C. So ask yourself what operation C wants us to perform. Notice the dot, that's multiplication, so we're going to multiply these. Okay, f of x is 5 minus 2i. Always use parentheses, guys. I'm telling you. G of x is 3 plus 6i, and we're going to multiply. Well, now would be appropriate time to go ahead and distribute. Okay, we're going to multiply 5 times this 3. I'll get 15. To the second term now, 5 times 6i is plus 30i. Now I'm going to distribute the second term, which is negative 2i times 3 is minus 6i. And then negative 2i times positive 6i, you have to watch your signs here. That's going to be a negative 12. And what's I times itself? That's going to give me I squared. Hey, we talked about this earlier. Whenever you see I squared, you will immediately replace that with a negative 1. So I'm going to rewrite this. This is 15 plus 30i minus 6i minus 12 times negative 1, which is really going to give me, I'm going to go ahead and highlight this. Negative 12 times negative 1 turns into a positive 12. So we have a plus 12 over at the end. Let me go ahead and erase that, write the plus 12. Okay, now we can combine our like terms. We're all distributed. We fixed our I squared. So 15 plus 12, these are my like terms, gives me 27. And then 30i minus 6i gives me plus 24i. And there you have it. That's number 2. So the biggest mistake here is to do the wrong operation. Let's look at if you needed help, if you used my help to guide you through these problems, but now you want to test yourself, see what you're really capable of, go ahead and write these down, okay? Copy down the problem, pause the video, and at the end I'll show you the correct answers. All right, let's go on to number 3. 3 says solve. So what we're dealing with here is a quadratic equation. I know it's a quadratic because quadratic means it has an x squared term in it, and there it is. So when we're solving quadratic equations like this, you have a couple of methods that you can use to solve. The first method that we use always, every single time, if it's possible, is GCF, or greatest common factor. Okay, if these notes are new to you, you should go ahead and write them down because they will be very helpful. Next, if we have two terms, just two terms, and there's a minus sign between them, you might be dealing with a difference of squares, which works out like that. We'll see that in a bit, okay? Just write these down for now. So how to solve a quadratic equation. And then the third option is if you have three terms in this format. You're going to go ahead and use magic X or some other method of factoring. Or Punnett square. Okay, so these are our three options. So let's see what we have here. Well, this is in this form, ax squared plus bx plus c. I see because I have this x squared, the x, and there's my constant at the end. But it would be actually foolish to jump into magic X if I don't check GCF first. Always check. Is there something you can pull out from every term before you begin factoring with the other methods? And in this case, if I look at the numbers 2, -16, 30, and I ask myself, what's the biggest number that multiplies into every term? Then I would say, oh yeah, 2. 2 goes into everything. So I can factor out a 2, or sometimes your teacher might just divide every term by 2. That's fine as well. But if I pull out a 2, then what's left on the inside is x squared minus 8x plus 15. I can close my parentheses and set it equal to 0. So now in case you didn't know how I got that, I just divided every term by 2 to see what was left on the inside. So 2 times x squared gives me 2x squared. 2 times negative 8x would give me the negative 16x. And then 2 times 15 gives me positive 30. So you just need to make sure that when you pull a number out in front, you're filling inside appropriately. Okay, let's go on. Now I'm asked to factor this piece. So it's still in that form. It's still a trinomial, ax squared plus bx plus c. So I'm going to go ahead and magic X this. So the two numbers that multiply to 15, right, because it's this guy times this guy, but then add up to -8. Okay, if I need to multiply to 15, but add to -8, let's try 5 and 3. Now when I add them together, I get a positive 8. But if they're both negative, then I still multiply to a positive and add to -8. Those are the two numbers I'm interested in. So I'm just going to continue copying down this 2, but now I know that I can use my shortcut, and this would be x minus 5 and x minus 3. My next step, now that I'm fully factored, is to set each factor equal to 0. So x minus 5 equals 0. Adding 5 to both sides, I get x equals 5. And then x minus 3 equals 0. Adding 3 to both sides, I'll get x equals positive 3. And these are my two answers, x equals 3 and x equals 5. All right, if you want to try one yourself now. Oh, by the way, there's one more option. The fourth option, if everything else fails, is called the quadratic formula. Yay for this beast of a formula. You have to use it carefully, but it's not hard. It's negative b plus or minus square root b squared minus 4ac all over 2 times a. Okay, so that's our final option to solve a quadratic equation if factoring doesn't work. So now, if you got that, you want to try one on your own, go ahead and try number 3. 3b, right? So I'll show you the answer at the end. Let's move on. Another quadratic equation. So notice what's different about this problem. Usually, we have to have everything set equal to 0. That's the most important thing. So the first thing, so you must, make a note to yourself, must set all terms, or let me rewrite this, must move all terms to the same side first so that you can set it equal to 0. So I need to get rid of this 5 over here. The way I'll do that is by subtraction. And lining up my like terms, I just get 2x squared plus 3x minus 5 equals 0. Now I can think about those methods we talked about earlier. Is there a number that can multiply evenly into 2, 3, and 5? Well, it's not 2. It doesn't seem like there is a number. Nothing goes into all those. So next option is to go ahead and do magic x. So we need two numbers that will multiply to the negative 10, multiply 2 times negative 5, right? That's how I got negative 10. And then it has to add up to the middle term, which is positive 3. Can you think of numbers that multiply to 10 and add to 3? Add or subtract. So the numbers would be 5 and 2, but one of them has to be a negative. I'll make the 2 a negative so that 5 minus 2 adds up to 3. So watch the most common mistake kids make right now. They'll go x plus 5 times x minus 2. Well, that doesn't actually make sense, does it? Because think about it. X times x gives me x squared. But what do I need in the front? I need 2x squared. So you cannot use the shortcut because of this 2 in the front. Make a note to yourself, no shortcut. So the way we go about solving this is we'll split up the middle term. This is going to be 2x squared, and I'll copy these down, 5 and then negative 2. So plus, that's a positive 5x, followed by a minus 2x, that's from here and here, minus 5 equal to 0. I'm going to factor by grouping, so we'll underline the first two terms and underline the second two terms. Right now I want you to just focus right here, okay? So what can we pull out from a 2x squared and from a 5x? Well, they both have an x to give me, but there is no number that I can pull out. So I'm left with 2x plus 5 inside my parentheses. Now we know if this parentheses is 2x plus 5, then the second one will also be 2x plus 5. So that missing number right here is going to be a minus 1. So when I multiply it in, I get the negative 2x minus 5 that I needed. So we're really close to being done here. The guy that's the same will copy it down. And then my leftovers are this x and this minus 1. They get their own parentheses as x minus 1. Set it equal to 0. We're almost done. Each factor now will turn into its own equation. So we have 2x plus 5 equal to 0 because of the 0 product property. And x minus 1 equals to 0. Let's do some basic arithmetic to finish this problem. On the left side, I'll get 2x equals negative 5. Then when I divide by 2, I get x equals negative 5 over 2 as my first answer. On the right side, I'll add 1 to both sides. I'll get x equals 1. And these are my two answers. X equals negative 5 halves and positive 1. The way I did that is by first checking GCF. Didn't work. Then I recognized I had a trinomial, so I used my magic x. Let's give you another problem to practice on your own, okay? 4b, write it down if you want to test yourself. I'll show you the answer at the end. So this is a solve for x. You should get two answers. Let's go on to number 5. 5 says solve another quadratic equation. So what do we always do first? We'll always check if there's a greatest common factor. Is there some number that multiplies evenly into 2 and into 4? Indeed there is. That number is a 2. And I can also factor out an x, because here I have 2 x's, there's 1. So we can factor out 1x. And now we're left with some parentheses. Okay, 2x times what will give me 2x squared? What needs to go here? Well, it has to be an x. Now for the second term, 2x times what will give me the negative 4x? It'll just be minus 2. So now I'm going to set it equal to 0, and I'm fully factored. set each factor equal to 0, and solve. That one was actually really fast and easy. You just have to recognize that this was a GCF problem, and as soon as we pulled out the 2 and the x, we were done, actually. So we're almost finished. Let's divide each by 2. We get x equals 0, because 0 divided by anything is 0. And for the second one, I'll add 2 to both sides, and I'll get x equals 2. These are my answers. So I'll show you another one so you can recognize how quick and simple it can be. And then we'll move on. So 3x squared, let's say, plus 12x equals 0. So again, the number that I can factor out from both of these terms is a 3, and then they can also give up an x. Now I have to just decide what goes inside the parentheses. So again, 3x, we're going to have 2 terms because we have 2 here. So 3x times what gives me 3x squared? All I'm missing is an x. And then 3x times what gives me plus 12x? Well, all I'm missing is a plus 4. And now I'm ready to solve. 3x equals 0, x plus 4 equals 0. I get x equals 0, and x equals negative 4. So these problems don't have to be difficult, right? If you pull out and then you're ready to solve right away, then you're good to go. We don't have to use magic x every single time. So try this problem yourself. My hint here is to factor out the negative, right? Divide every guy by -1 first, and then move on. Okay, let's go to number 6. It says solve. Okay, another quadratic equation. So here we'll, again, check if there's anything that we can factor out by greatest common factor. So is there a number that goes into 49 and into 36 evenly? The only number that really multiplies into 49 is 7 and 49 itself, and neither one of those goes into 36. So we won't be doing a greatest common factor. Also notice, this guy doesn't have an x to offer, so we can't factor out an x either. So we're stuck with this binomial, and actually, if you notice, there's something special about it. It's a difference of squares. Because there's a minus sign in the middle, meaning it's a difference. And then this guy is a perfect square. And this is a perfect square. Here's what I mean. What times itself gives us 49x squared? What times itself? Well, the 7 times itself gives me 49, and x times itself gives me x squared. So I'll write that down. That's in my first parentheses. Now, 36 is also a perfect square because 6 times itself gives me 36. And the way that difference of squares works is, my friends, you simply find the root, just like we just did. We found the root of each, and we put one with a minus sign, and we put one with a plus sign. So that's what we're going to do. You just copy it again. So we have 7x plus 6 and 7x minus 6. Let me show you another one. And we'll finish the problem in just a second. 25x squared minus, 30. No, we just did that. 25x squared minus 64. So again, I have a difference, because of the minus sign, of 2 perfect squares. So let's take the square root. That would give me 5x. This guy would give me 8. And difference of squares goes 1 plus, 1 minus. Super nice. Another one, x squared minus 9. So I have a difference because of the minus sign. This is a perfect square, and so is that guy. So I'm going to have x minus, and the root here is 3, times x plus 3. Okay, so difference of squares is not difficult to identify, but I'm gonna ask you to go ahead and try finishing this problem. So set each factor equal to 0. That's the left parentheses. This one is the right parentheses. And we'll solve the left one first. So we're going to subtract 6. I'll get 7x equals negative 6. I'll divide by 7. And I get x equals negative 6 over 7. Over here, I'm going to add 6. I'll get 7x equals 6. Then I'll divide by 7. And get x equals positive 6 over 7. So in your answer sheet, it should say x equals, since they're the same number, plus or minus 6 over 7. That takes care of my positive version and my negative version. So if you got the hang of how difference of squares works, go ahead and try these problems to get some additional practice. These are all difference of squares. Pause the video, write them down, and now we're going to move on to number 7. Okay. 7 says, find the center and the radius. So I know I'm dealing with a circle here because x is being squared, but so is y. So we need to get this guy into a form that we're familiar with. Here's the format, the standard form for a circle. X minus h squared plus y minus k squared equals my radius squared. Right now, this looks nothing like that. There's no parentheses. There's nothing as my radius, right, on the other side. I need a number here, not 0. So there's a lot of work we need to do. So let's begin first of all by getting number 1. So let's group our x's, our y's, and move the constant, which is just the number all by itself. Move the constant to the other side. Let's get this prepped, okay? So we'll get our x's together. Here are my x's. So I get x squared minus 4x. And I'm going to go ahead and leave a blank here so I can complete that square. And eventually this will turn into something like looking like that. Plus, now I'm going to get my y's together. Y squared plus 6y, leave a blank. And I want to get this number to the other side. So the way I'll do that is I'll add 3 to both sides. And I just get equals positive 3. Now I need it, whatever I do to the left side, I'm going to have to do on the right side as well. So I'll leave 2 blanks here. Okay, guys, we're ready to complete our square. Here's how it works. I need to rewrite x squared minus 4x, and there's a missing number, as something times itself. So the way we figure out what this missing number is we'll divide b by 2. So negative 4 divided by 2 gives me negative 2. So I have x minus 2 times x minus 2. Notice that I included the sign. And the reason that works is when I have negative 2x minus 2x, that will leave me with a negative 4x in the middle, which is what I needed. But now the missing number is going to be from this times itself, negative 2 times negative 2, which is a positive 4. Since I added 4 on the left, I will go ahead and add 4 on the right. Let's do the same thing with our y's now. Keep that plus sign in the middle. This will be y, and divide this guy by 2 to figure out that's going to say actually y plus 3. Times y plus 3, and the missing number would be positive 9 because of this 3 times itself at the end. This times itself. Now if I added 9 to the left side, we got to do it on the right. So we'll get equals, well, 3 plus 4 is 7, plus 9 is 16. And now we're really close. We just have to write this in a way that matches our formula. Okay, so this is going to be x minus 2 squared, because it's times itself, plus y plus 3 squared equals 16. And now, my friends, we are in standard form. And we can identify our center and our radius. So our center is going to be, well, we'll flip the inside number in both cases. So it's going to be positive 2 in the x, negative 3 in the y. And this 16 represents not my radius, but look, that 16 actually represents my radius squared. So I'm going to set up a quick equation. My radius squared equals 16. So that means to get my radius all by itself, I have to take the square root. So my radius is just 4. And there we've answered the question. Find the center and the radius. Now number 8. Super easy. We just have to plot it. Let's go to our center first. Go to positive 2 on the x, negative 3. Draw a point. And now we have to count 4 in each direction. So if I go up, 1, 2, 3, I'll get a point over here at 2, 1. If I go over 4, I'll get a point here at what looks like 6, negative 3. I'll go 4 down. That'll take me to negative 7. And I'll go 4 back, 1, 2, 3, 4, which will take me to negative 2 on the x. Okay, let's draw our circle. There we go. So yours will look, more or less like this. It doesn't have to be a perfect circle, but your points should be 4 up, 4 down, 4 in every direction. All right, so if you want to try one yourself now, go ahead and write down 7b. Remember, first you're going to group your x's, leave a space after them, then group your y's, and you're going to want to also, finally, don't forget, move this number to the other side. Go from there. Okay. Let's move on to our next problem, number 9. Ooh, I love this problem. It's already in standard form, and all we have to do is graph it. So to graph, let's label our center. As before, we'll flip both of these numbers. So it's going to be a positive 3, negative 2. Right? This changed from a negative 3 into a positive 3. We changed this guy from a positive 2 into a negative 2. That's the same thing that we did up here, right? It was negative. Whoops. This was a negative, but we wrote down the positive version. And this was a positive, but we wrote the negative version. So that's the pattern. And then this 4 represents my r squared. So if I want to find just my radius, we'll have to take the square root. And we'll find that r is equal to 2. That's our radius. Using these two pieces of information, we can graph. Go to positive 3, negative 2. We're going to count up 2, over 2, down 2, and back 2. Oh my god, my circle is honestly horrendous. I hope yours are better than mine, although it doesn't really matter that much. Oh, I know why. I made a mistake. So count carefully. Back 2 would actually take me to this point. So here are my points. I have one at 3, 0, one at 3, negative 4, one at 5, negative 2, and this one over here is at 1, negative 2. Okay, if you got number 9, and you want to practice once again, go ahead and graph this. I'll show you the answer at the end of this video. Go ahead and test yourself. Right now, while the information is still fresh in your mind. Find the center, find the radius. All right, moving on. Number 10 wants us to graph this function. So here's the nice thing about this function is, so right now I'm graphing a quadratic. I know it's a quadratic, not a circle, because only x is being squared, right? You don't see this guy saying y squared, just y. So I know I'm graphing a quadratic, and the nice thing about this is it falls in this format. In this format, we call it vertex form. So in your notes, go ahead and write vertex form next to this. Since we have those parentheses, we can easily find our vertex. So quick reminder, to find your vertex, you're going to flip the inside number. So we would actually get a -1 in the x position. And then you're going to keep the outside number exactly as it is. So we'll get a +1, right? We didn't flip that one. And then you'll plot that. That's our vertex at -1, whoops, wrong place. Go to -1 on the x, +1 on the y. Next, you can ask yourself if this is opening up or down. And that depends on the number in front, whether it's positive or negative. Right now, there's nothing in the front, so that means it's positive. So I know I'm going to be opening up. But I want to be more precise than that. I want to know exactly where it's hitting. So let's find one more point. Let's go ahead and find the y-intercept. So quick note for yourself. The y-intercept is always found by setting x equal to 0. So if you want to find out what the y is, you have to set x equal to 0. So you're going to end up with a point where 0 is in your x, and we need to figure out the y value. Well, if I know the x is 0, all I have to do is plug in 0 right here into my x. So I'm going to do that. Let's plug it in and see what we get for y. Well, y is equal to, I'm just plugging in 0 right here. Parentheses, 0 for x plus 1 squared plus 1. Using my order of operations, I'll do the inside of the parentheses first. So, parentheses first, that means I'm going to get y equals 0 plus 1 is 1, squared plus 1. Next, I'll do my exponents. So 1 times itself is 1 plus 1. There's no multiplication, no division, so I'll add y equals 2. So our y-intercept was 0, 2. How did we get that? Once again, we set our x equal to 0 and just figured out what we got at the end. 0, 2 takes me here, and I know I'm facing up, and this is the vertex, so that means it's the turning point. So we'll go ahead and draw our parabola through those points. Okay. If you felt comfortable with that, you want to try another problem on your own, go ahead and write this one down. Graph the function x minus 3 whole squared. So notice here we're actually missing an outside number. So you have to ask yourself, what number is really being added at the end if it's invisible? It's not going to be 1. Okay, it's something else. I'll just tell you it's 0. Okay, whenever you're missing an inside number or an outside number, that number is 0. Go ahead and graph it from there. All right, let's move on to number 11. It says graph this function. We have another quadratic function, but this time it's in standard form instead of vertex form. So instead of being like this, it's like this. It's all spread out. There's no parentheses. There's no inside and outside. So we have to use some different tricks. So we're going to find 3 things. Okay, write them down with me. First, we'll find our vertex. The way we find the vertex, since we can't flip the inside, keep the outside here, is you're going to use this formula, and you should put this down on a note card somewhere. X equals negative b over 2a. That'll give us our x value. And then we plug that in to find the y value. Because remember, vertex, you need an x and a y. So that's going to be our first job. After we find the vertex, we'll go ahead and find our y-intercept. We remember how to find the y-intercept. You have to set the other guy, x equal to 0. That will be our second big job. And then finally, we will find our x-intercepts. Your x-intercepts are found exactly the opposite way as your y-intercepts. To find the x, you have to set y equal to 0, or f of x equal to 0. So let's go at these one at a time. Let's find our vertex first. So here we go. Finding the vertex requires that we use this formula, x equals negative b over 2a. Well, what do we mean by a and b? Of course, we're talking about the numbers in front of x squared and x. So in this case, my a is the invisible number in front of x squared, which is a 1. And my b is the number in front of x, which is not 2, but negative 2. So the sign matters. So I'm going to go ahead and plug these in carefully. Negative, and now what's my b? My b is negative 2, so you have to have that double negative there. The first one is just from the formula, and the second one is your b. All over 2 times a, which is 1. Let's finish this. The top becomes a positive 2, the bottom becomes 2. 2 divided by 2 leaves me with 1. So I know that in my vertex, at least I'm halfway done. The x value is 1. Now I need to find the y value. The y is unknown. Well, how will I find it? Plug in x equal to 1. You're going to have to plug it in here and right here. So let's see what happens. Write down y equals, let's plug in 1 for x. That's basically 1 squared minus 2 times 1 minus 3. Okay, order of operations says you're going to do your exponents first. So we'll get y equals 1 minus this. Okay, next we're going to multiply 1 minus 2 minus 3. And finally, we will combine everything. 1 minus 2 is negative 1. And negative 1 minus 3 is negative 4. Ta-da! So you can probably work that out a lot faster than me, but I'm showing every single step. So now we got our vertex as 1, negative 4. Next step, we're going to find our y-intercept. So your y-intercept, remember, you're going to have to set x equal to 0. So that means 0 squared minus 2 times 0 minus 3. Let's see what we get as our answer. Well, 0 squared disappears, becomes 0. 2 times 0 disappears, becomes 0. So we're left with 0 minus 3, which is just negative 3. So here's the point. When x was 0, because that's what we plugged it in for, our answer was negative 3. So far, we've got 2 very useful points to plot. In fact, we could be done there. But let's go ahead and find our x-intercepts also. X-intercept says you have to set the y equal to 0. So here's what we're talking about. This guy, set it equal to 0. That's our y value. So I'm going to draw a line. We'll find our x-intercepts now. So if I'm setting y equal to 0, this is going to be x squared minus 2x minus 3 equals 0. And then look at that. We have a quadratic equation to solve. Since there's no greatest common factor, we can go ahead and magic x this. Pause the video, try it yourself. So I need x's in these positions, and now these numbers should multiply to negative 3. So I'm going to try 1 and 3, but then they should add to negative 2. So the 1 should be a positive, the 3 negative, because that way I'll have positive 1x minus 3x, which leaves me with negative 2x. And that's exactly what I want in the middle. All right, so we're almost done here. But when we set each of these guys equal to 0, we get on the left side x equals negative 1, and on the right side x equals positive 3. So these are our x-intercepts. We set y equal to 0, and we got negative 1, 0, and 3, 0. Let's put all of these together on a graph and see what our graph looks like. Okay, here we go. So first things first, our vertex is at 1, negative 4. And I know that's my turning point. My y-intercept is at 0, negative 3. So I'm going to be facing up, right? But then my x-intercepts are at negative 1, 0 and 3, 0. So I need to go through those points. Ta-da! And I know I did this correctly because, check it out, it's positive in front, so I know I need to be facing up, and I am. So I'm very proud of myself, and you, if you followed along, should be proud of yourself too. Try 11B yourself. Keep these in mind. You need to find number 1, the vertex, or let's call this A. Okay, first part is identify the vertex. Remember the formula for it. This is not in vertex form, so you have some work to do. Next, you'll find the y-intercept, which is actually, in my opinion, the easiest part. You just plug in 0 for your x's. And then C, you'll find your x-intercepts. Remember, your note for that is to set the y equal to 0. Remember, for your y-intercept, you'll set the x equal to 0. It's basically flips. And then for your vertex, see if you remember the formula. In standard form, it's x equals negative b over 2a. Okay, go ahead, give it a shot. Okay, let's move on to number 12. Okay, number 12 says to find the x-intercepts and all these things from the graph. So it's basically like, do you know how to read the graph? Well, x-intercepts means I have to be, where am I hitting the x-axis? So I'll be hitting the x-axis in 2 positions here. We have to label those points. Those points are going to be, well, x is positive 1, 1, 0, that's that first point. And then my second x-intercept is when x is 5. Because I can count 1, 2, 3, 4, 5, okay? Next, let's find the axis of symmetry. So that's the line that divides this guy evenly in the middle. I know my axis of symmetry has to go through the vertex. And now this line is going to be going through the point where x equals 2. So that's the axis of symmetry. It's the line x equals, oh wait, that's actually positive 3. And I could go ahead and label my my vertex here as well. It's at 3, 1, 2, 3, 4. 3, negative 4. And your axis of symmetry will always go through the x. Right there, x equals 3. All right, let's find our y-intercepts. Your y-intercept is where you hit the y-axis, which is up and down. So it's this point right here. Our x value is 0, but our y value is 1, 2, 3, 4, 5. Our domain is all the values of x that this guy covers. So looking at these arrows that point left and right, I know my domain is going to be negative infinity to positive infinity because it's going to go forever to the left and forever to the right. That's what those arrows indicate to me. So that the range would be the x values. So the domain is the x values. Now the range is our y value. So you need to scan this graph from the bottom to the top. Okay, does my graph exist down here where y is negative infinity? No, it doesn't. It doesn't actually begin existing until right around here, correct? So the y value that it starts at is negative 4, so from bottom to top. The lowest it reaches is negative 4, and then it goes up, up, up forever to positive infinity. It's important you get this correct in the right order. We wouldn't say infinity to negative 4 because that's going backwards. Okay, so you have to go bottom to top. So from negative 4 to infinity, and we'll put brackets on the negative 4 since we actually include that in our y values. We hit negative 4. Next, we want to see where this guy is decreasing. So we will trace it from left to right. Starting at the left, is my graph decreasing right now or increasing? Well, if you follow my pen from left to right, you'll see I'm actually going down. And now I start increasing, so I want to back up a little bit. I'm decreasing on this portion of the graph. And after that, I start going upwards. So we're decreasing from the leftmost part of the graph, which is negative infinity, all the way until right here. The x values are negative infinity until positive 3. Okay, there is no number 12 for you here. So I'm going to give you a freebie. But please ask your teacher questions if you're not sure how we got any of these, because it's a lot easier to understand this when someone is working with you in person. If you're having trouble here, please go and ask your teacher. Okay? Hopefully that helped. Number 13 says, given this, so it's our last one, you guys. I'm so proud of us. 13 says, given this function, identify a few things. So first, x-intercepts. We took notes on this. To find the x-intercepts, we set the y equal to 0. Let's do it, and let's be efficient. Ready, set, go. We're setting our y value equal to 0, so it's going to look like this. X squared minus 2x minus 15 equals 0. First check. Is there a number I can pull out from all terms? Well, this has a 1 in front, so there is not going to be a number I can take out or that goes evenly. Next, our option is, since it's a trinomial, we'll do our magic x. Do whatever you need to do. I'm going to go ahead and do it this way. So I need x's in the first spot. Now my next terms need to multiply to negative 15, and they have to add up to negative 2. So let's try 5 and 3. But for them to add to negative 2, the 5 should be negative. And then that way they'll multiply to negative 15. So negative here, positive here. Now, if you're doing magic x, keep in mind that here you can use the shortcut because the number in front is just 1. So you just take these numbers and stick them right in. X minus 5, and this would be x plus 3. We're almost done. We need to solve for x. So on the left side, we'll get x equals positive 5. And on the right side, I'll get x equals negative 3. Ta-da! Those are our x-intercepts, so we need to actually write them as points. So when x is 5, we had set y equal to 0, and then we also have at negative 3, 0. Now let's find our axis of symmetry. So let's think about this for a quick second. We know that we have 1, 2, 3, 4, 5. That's our first x-intercept. And our other one was at negative 3. And this is a parabola that's opening up or opening down. Look out in the front. There's nothing there, so it's positive. That means this is opening up. Now, I don't know exactly where my axis of symmetry is, but if I count, I can figure it out. It has to be exactly halfway between these points, right? So if I have, let me count this out. 1, 2, 3, 4, 5, 6, 7, 8, right? There's a distance of 8 between these two. Then my axis of symmetry is going to be right in the middle. So I'll have to count 4 in each direction. So 1, 2, 3, 4 takes me right here. This is where my axis of symmetry would be. So if I were to draw a nice graph, then it would turn right exactly at the axis of symmetry. And what is that value that it goes through? It goes through x equals positive 1. Now, if you don't really like that method of counting it out, you could find your vertex first, which is f, find out what that point is, and then it's the x value. Actually, why don't we go ahead and do that right now? Let's find the vertex while we're at it, while we're talking about it. So look at the form that you're in. This is not in vertex form, so you're going to have to use our formula. X equals negative b over 2a. So let's label our a and our b right now. Our a is the invisible number in front, which is a positive 1. And our b here is negative 2. Let's plug them in. X equals negative b, which is negative 2, over 2 times a, and my a was positive 1. Okay. That'll give me a positive 2 on top, 2 on the bottom, which leaves me with 1. My vertex is 1 comma something. before I figure out what that y value that's missing, notice that the x value matches. Okay, let's go ahead and find our y value now. So we're going to need to figure out what y equals when our x is 1. We're going to plug in 1 here, and we'll plug it in, whoops, not there, but right here. Ready? 1 squared, okay, minus, so look here with me, minus 2 times 1, and then we have a minus 15 at the end. All right, let's use our order of operations, parentheses first. So there is nothing to do in here, so I'll move on to exponents. That's 1 minus, now I can multiply, minus 15. Now we just add and subtract. So 1 minus 2 is negative 1. Minus 15 is negative 16. That would be our missing y value for our vertex. So we got 1 comma negative 16. 1 negative 16. There we go. We are making great progress so far. Let's find our y-intercepts now. We're at C. So for our y-intercepts, we set the x is equal to 0. We can do that real quick like this. Y equals, instead of x squared, we'll put 0 squared. Instead of minus 2 times x, we'll put minus 2 times 0. We're setting our x equal to 0. Minus 15. Notice what happens. This disappears because 0 times itself is just 0. This disappears because anything times 0 is just 0. And we're left with 0 minus 15, which is just negative 15. So our y-intercept is 0 comma negative 15. We set x equal to 0 and we found out our y value. Let's highlight that and move on. Okay, next it says find a maximum. Find out if this is a maximum or minimum. So again, we know that our graph is facing up because there's a positive out in the front. So that means that our graph has a minimum point. Now finally, I shouldn't have erased that actually. Finally, let's talk about our end behavior. Since this is facing up, I know that both when x is approaching positive infinity, which is this right side, and when x is approaching negative infinity, which is this left side, our y values, our height, is going up towards positive infinity. We're going up forever on both sides. Now, if our graph had been facing down, then we would have said, oh, our graph is going down towards negative infinity. But it's not going down, it's going up. So we'll say positive infinity on both sides. If you notice, we're actually all done with the problem. Let me highlight our answers really quick. Our x-intercepts, there they are. Our axis of symmetry was 1. Our y-intercept was negative 15. Oh, I chose the wrong answer here. So this was actually a minimum. Because it was facing up. So we had a min. We have our end behavior all filled in and our vertex. If you're ready to give this a try on your own, write down number 13B and pause the video because I'm about to show you all of the answers. Okay. So if you followed and you wanted to try some on your own, here are those answers that I promised you. First, the square root of negative 18. Looks like this. Since there's a negative inside, that makes this imaginary. Next, negative 5 over 9. So there is a negative, but it's not inside a square root. Therefore, we just have a regular negative number. This is real. Next, I have 2i cubed, so you have to do some work. We'll write this out, following the instructions, multiply it by itself 3 times. Okay, let's go 2 at a time and multiply these together. 2i times 2i gives me 4i squared. I still have that remaining, that third one I need to multiply with. But right away you should notice I squared gets replaced with -1. So 4 times -1 really gives me -4 times 2i, which is -8i. Since we still have an I, that means this is imaginary. Okay, the last one, negative square root 23. This would be real because the negative is outside. If the negative was inside, then it would have been imaginary. Let's go to number 2. So f of x minus parentheses g of x required you to distribute the negative. And when you do all that, the answer that you should get would be 2 minus I. For letter E, you're multiplying them out. So you'll distribute all of these, and the answer you should get is 13 minus 11i. Finally, for F, you are simply adding them together. So 5 minus 2i plus 3 minus I, you're ready to combine like terms, and the answer that you should get is 8 minus 3i. Let's go on to number 3. It says solve. Now you might have checked for GCF first. There's nothing you can factor out. So actually, magic X doesn't work here either, because I need two numbers that multiply to 10 but add to 4. You'll notice that nothing works. So in your last resort, you're going to have to use the quadratic formula. I'll label my A equal to 2, B equals 4, C equals 5. Plugging it in carefully, I get negative B plus or minus the square root of B squared minus 4 times A times the C, which is 5, all over 2 times A, which is 2. Let's simplify this one step at a time. That's negative 4 plus or minus 16 minus, okay, here we go. 4 times 2 is 8. 8 times 5 is 40. All over 4. 16 minus 40 will give me, look at how carefully I'm working this out. 16 minus 40 will give me negative 24. And I'm almost done. I have to simplify this. So off on the side, I'll see what the square root of 24 is, which is 2, 12, 2, 6, 2, 3. So it's going to give me negative 4 plus or minus 2, because I'm pulling out the doubles. Square root, these multiply back inside as 6. Now I've missed something critical. See this negative inside? That should give me an I. So I'm going to write it correctly. Negative 4 plus or minus 2i square root 6, and it's all over 4. We're almost done, but we have to break this apart so we can simplify. You'll get x equals negative 4 over 4 plus or minus 2i root 6 over 4. Just give me a quick second. Okay. Now on the left, that'll leave me with negative 1 plus or minus, and on the right, the 2 and the 4 will cancel with the 2 at the bottom. So I'll have I root 6 all over 2. And those are my two answers. Whew! What a doozy. Okay, so you will have one like this on your test. Be prepared. For B, move everything to the same side first. 8x squared plus 16x minus 10 equals 0. And then notice that you can factor out at least a 2. I'll be left with 4x squared plus 8x minus 5 equal to 0. Now, whichever factoring method you use, you'll find that this actually factors into 2x minus 1 and 2x plus 5. Solving, you'll get x equals 1/2 positive and x equals negative 5/2 negative. Number 5. This one will be solved with GCF. First, I'll divide everything by negative 1. I'll get 8x squared minus 12x equals 0. And now I can factor out the number that goes into 8 and into 12 is 4. I can also pull out an x, and I'll be left with 2x minus 3. So my two answers will be x equals 0 and x equals positive 3 over 2. Number 6, this was the difference of squares. So this will factor into 3x minus 2, 3x plus 2. Remember, you take the root of each term. That's how I got the 3x. You take the root of the second term. That's how I got the 2. Then you just flip the signs, a minus version and a positive version. So our answers here are x equals positive 2 over 3 and negative 2 over 3. Over here, this factors as 2x minus 1, 2x plus 1. So my answers are x equals positive 1/2 and negative 1/2. Finally, this will factor as x minus 9 and x plus 9. So my answers are x equals 9 and negative 9. Moving on to number 7, we group our x's first. So I get x squared minus 6x, leave a space. Y squared plus 2y, leave a space. And I'll add the 6 to both sides to start. Next, I'll divide these by 2 to tell me what goes in my parentheses. So for my x's, I'll be minusing 3 because negative 6 divided by 2. For my y's, I'll be adding 1 because positive 2 divided by 2. Now the missing number is going to be this guy squared times itself, which is a plus 9. I have to plus 9 on this side. And over here, 1 times 1 gives me plus 1, so I'll plus 1 on this side. So next I have x minus 3 squared plus y plus 1 squared equals the square root of, equals 6 plus 9 is 15 plus 1 is 16. And so now I'm ready to tell you the center, which is positive 3, negative 1, because I flipped, and my radius, which is 4. To graph it, go to 3, negative 1, count up 4, count over 4, back 4, and down 4. Ta-da! Number 9, again, find the center. So flip that, it becomes a positive 1. Flip the y, it becomes a negative 3. And for your radius, remember your radius squared equals 1. So take the square root. Square root of 1 is 1. So we go to 1, negative 3. Go up 1 over 1 in every direction. We have a tiny little circle. Okay, let's go to number 10. Graph the function. So this is in vertex form. The missing number outside is 0, so my vertex will be flip the inside, becomes a positive 3, keep the outside number, stays 0, and then this is opening in the positive direction. I can also find my y-intercept. I can do that by setting x equal to 0, so y equals 0 minus 3 squared. And I'll find out that y equals negative 3 squared, which is positive 9. So my y-intercept is 0, 9, and I'm ready to graph. Go to 3, 0. It's opening up, but it should go through 6, 7, 8. This y-intercept all the way at positive 9. Now your graph should be a little prettier and more symmetrical than mine, but that's essentially it. Let's go to number 11. We'll find our vertex first. If you do x equals negative b over 2a, and you've labeled your a and b carefully, then you should get negative 4 over 2, which is negative 2 in the x position. Plug that back in to find the y values, which is 4 minus 8 minus 12, which is negative 4 minus 12, negative 16. So my vertex is going to be negative 2 for my x, negative 16 for the y. Next, I'll find my y-intercept. For the y-intercept, set x equal to 0, and you'll notice you're left with 0, negative 12. And for your x-intercept, so we know our y value is 0, and if I actually show the work, I'll realize, oh, I need to factor that. And those numbers should be positive 6 and negative 2. So x equals 6, x equals negative 6 actually, and positive 2. And now I'm ready to graph from all this. So let's go to negative 2, negative 16. I'm going to estimate it's right there. Next, I'll go to 0, negative 12. Go to positive 2, 0, and negative 6, 0 for a nice graph. That should go through all the points. Okay, mine's a little off. It should go right here. And then our last problem asked us to identify our x-intercepts. So again, we set the function equal to 0, and we will factor. I'll get x minus 8 and x plus 2. So that means my x-intercepts occur at 8 and at negative 2. Okay, before finding my axis of symmetry, I'll go to my vertex. I'll label my A and my B and plug it in. That's negative 6 over 2 times A, which is 6 over 2, which is 3, comma. Now I need to find the y value, so I'll plug that in. 3 squared minus 6 times 3 minus 16. Leaves me with 9 minus 18 minus 16, which is negative 9 minus 16, which is negative 25. And the reason I found my vertex first is because I know that the axis of symmetry will always be x equals whatever the x value is. X equals 3 here. Now my y-intercepts, I'll set the x value equal to 0. Just like that. Disappears. I'm left with 0, negative 16. I know that this is facing up because it's positive on the outside. So that means I'm dealing with a minimum. And since it's going upwards to y approaching positive infinity, both on the right side and on the left side. And that, my friends, captures our study guide number 2, as well as these hidden practice problems for you. I hope you feel a little more confident, and I'll see you next time.